Welcome to today's exciting video on comparing two of the most popular AI frameworks, TensorFlow and PyTorch. If you're diving into machine learning or artificial intelligence, choosing the right framework can be a game changer for your projects. Both TensorFlow and PyTorch have revolutionized the way developers approach AI, but they each come with their own unique strengths and weaknesses. In this video, we'll explore both frameworks, their features, and help you decide which one is best suited for your needs. Let's start with a brief overview of each framework. TensorFlow, developed by Google Brain, was released in 2015. It's known for its scalability, performance, and versatility. TensorFlow is highly optimized for both research and production environments, making it a great choice for companies looking to deploy machine learning models at scale. PyTorch, on the other hand, was developed by Facebook's AI Research Lab and released in 2016. It quickly became the framework of choice for many researchers due to its dynamic computation graph, which makes it more flexible and intuitive for experimentation. PyTorch is often preferred for research and development, thanks to its ease of use and debugging capabilities. One of the most significant differences between TensorFlow and PyTorch is how they handle computation graphs. TensorFlow uses a static computation graph, meaning that the entire graph must be defined before any operations can take place. This makes it efficient for large-scale deployment but can be cumbersome when you need to make real-time changes or debug your model. PyTorch, on the other hand, uses a dynamic computation graph. This means that the graph is built on the fly during execution, which makes it easier to modify and debug. If you're working on a new model or experimenting with different architectures, PyTorch's flexibility allows for quick adjustments, giving you more control over your model. When it comes to ease of use, PyTorch has a reputation for being more Pythonic and user-friendly. Its interface is more intuitive, and it integrates seamlessly with Python libraries, making it a popular choice among researchers and beginners. In fact, a 2021 survey by Kaggle showed that over 50% of data scientists and AI practitioners preferred PyTorch over TensorFlow, largely due to its simplicity and ease of use. TensorFlow, on the other hand, has a steeper learning curve, especially for beginners. While the framework offers extensive documentation and tutorials, it can be challenging to navigate, particularly when dealing with its low-level operations and static graphs. However, TensorFlow has made strides in improving its ease of use with high-level APIs-like keras, which simplify model building for newcomers. Another factor to consider is deployment. TensorFlow has long been regarded as the go-to framework for deploying AI models in production environments. With TensorFlow serving, TensorFlow Lite, and TensorFlow JS, developers can easily deploy their models across mobile devices, web browsers, and servers. This makes TensorFlow an ideal choice for large-scale, real-world applications like autonomous vehicles, recommendation systems, and AI-driven chatbots. PyTorch has historically been more focused on research and development, and while it has made significant progress in production deployments, TensorFlow still holds an edge in this area. PyTorch has introduced features like TorchScript and PyTorch Mobile, which allow for model deployment on mobile and embedded devices. However, TensorFlow's comprehensive deployment ecosystem remains a key advantage for production-level AI systems. When it comes to performance, both TensorFlow and PyTorch are highly optimized for deep learning tasks, but TensorFlow is often seen as more efficient for large-scale training and deployment. TensorFlow can handle distributed computing and parallel processing much more effectively, making it a better choice for high-performance applications and training models on large datasets. That being said, PyTorch has made significant strides in this area as well. With support for multi-GPU setups, PyTorch is now capable of training large models efficiently. PyTorch's eager execution mode, which allows for dynamic computation, makes it easier to debug models, but can slightly impact performance compared to TensorFlow's static graph. Let's talk about community support. Both TensorFlow and PyTorch boast large, active communities of developers, researchers, and enthusiasts. TensorFlow has been around longer and has a broader range of tutorials, resources, and third-party libraries. It's supported by major tech companies and is widely used in both academia and industry. PyTorch, though newer, has gained significant momentum in the research community, and its user base has been growing rapidly. In fact, PyTorch is now considered the most popular deep learning framework in academic papers and research. The PyTorch community is also incredibly active, with many contributors constantly improving the framework and sharing new techniques and resources. So, which framework should you choose? The answer depends on your specific needs and goals. If you're a beginner or a researcher looking to quickly experiment with models and prototypes, PyTorch's ease of use and flexibility make it a great choice. It allows for faster iteration and debugging, making it ideal for academic research and small-scale projects. On the other hand, if you're working on a large-scale application that requires efficient deployment across multiple platforms or need to train models on massive datasets, TensorFlow is likely the better option. Its scalability, performance, and robust deployment tools make it a go-to framework for production-level AI applications. In addition, TensorFlow has broader support for mobile devices, web browsers, and cloud platforms, making it the go-to framework for AI-driven apps in industries like healthcare, finance, and automotive. Of course, there are also hybrid approaches, where you can use TensorFlow for deployment and PyTorch for research. Many developers use both frameworks in different stages of their projects to take advantage of the strengths of each. One emerging trend is the use of Keras, which is a high-level neural network API that runs on top of TensorFlow. Keras simplifies the process of building and training models, and it's a great option if you want the ease of use found in PyTorch but also the scalability and deployment tools of TensorFlow. In conclusion, both TensorFlow and PyTorch have their strengths and weaknesses. TensorFlow excels in deployment, scalability, and production environments, while PyTorch shines in flexibility, ease of use, and rapid prototyping. Ultimately, the choice between TensorFlow and PyTorch depends on your goals, whether that's research, experimentation, or deployment at scale. I hope this comparison helps you better understand these two powerful AI frameworks and which one might be right for your projects. Be sure to experiment with both, as learning each framework can provide you with valuable skills to tackle a wide range of AI challenges. Thank you for joining us today. If you found this video helpful, don't forget to like, comment, and subscribe for more deep dives into the world of AI. Until next time, keep coding and exploring.